In this video, we're going to look at section 2.5, terms, coefficients, and like terms. So we're going to start with some definitions. These are all listed in your packet, so you have them written down already. You should read them before you watch a video, but I just want to go over a few key ideas. Okay. So a term of an algebraic expression or equation is either a single number, which we sometimes call a constant, a single variable, or a product, and by product we mean multiplication, of any combination of numbers and variables. So here's a few example of terms. Okay. Here's an example of an equation. On the left-hand side there's 3 terms, and on the right-hand side there's 2 terms. So terms in an algebraic expression or equation are connected by addition or subtraction. So basically I see a subtraction sign, an addition sign, and the 3 things between them, connecting them, are what we call terms. Now, the coefficient of a term is the number multiplied by the variable, or the constant itself if it is a constant term, when the expression is written using only addition. When finding the coefficient, you need to either rewrite the expressions using only addition, or use the fact that subtracting is the same as adding the opposite of a number. Okay. So I think the best thing to do is use the fact that subtracting is the same as adding the opposite of a number, but I just want to clarify this statement with the example. Okay. So here's the equation from the previous page, okay, and here I rewrote the equation using only addition. So by that I mean, instead of subtraction, I wrote it as adding a -2. Okay, so remember, subtracting is the same as adding the opposite of a number. So subtracting 2 is the same as adding -2. Okay. There's one other instance of subtraction, so I changed that to adding a -6x cubed. So when it's written using only addition, you can just look, the coefficient is just the number multiplied in that term. So here we have 3, -2, that's a constant term, 5, here we have 7, and here we have -6. Okay? So those are the coefficients of these terms. Now this is a lot of work to do just to get here. Okay? So in the original equation, you can look at it without doing all the work of rewriting it as addition, but if you see a subtraction sign, you have to think of it as adding a negative sign. So subtraction signs and negative signs are not the same. Subtraction is an operation. Okay? Subtraction and addition are operations. This is a negative sign. But it's not too much of a leap to look at this original equation and say the coefficient of 3x is 3. Think of the subtraction sign as a -1 times the 2. So the coefficient of this term, the constant term, is -2. Here we have 5. Here we have 7. And now here we think of it as -6 is the coefficient of -6x cubed. So here's a listing of the terms. Notice the terms, the ones with subtraction, include a negative sign, so we think of them as negative terms, and their coefficients also include negative signs. And finally, we're going to need to know about like terms. Okay. Like terms whose variable factors are equivalent. So like terms are terms whose variable factors are equivalent. So 3x and x, they are like terms. They're variable factors in x. Notice these 2 terms, they both have variable factors of x times y, so they are like terms. Here we have x squared t and x times t times x. Well, even though they're jumbled up, x squared t, well, that's 2 factors of x and 1 factor of t. Notice xtx also has 2 factors of x and 1 factor of t. So their variable terms are equivalent, so they are like terms. So we could rearrange these if we wanted to. Typically, we'd write the variable terms in this way, not this way, but they can be written in any other way. And finally, 5 and -2 are like terms. They're both constants. So now let's practice identifying terms, coefficients, and like terms. Complete the table below by listing each term and its corresponding coefficient for negative 3 minus x plus 4x squared over 3 minus y over 2. Okay? So we're specifically looking at this one because, hey, we have some fractions in here. That's a little bit weird. Okay? But we're going to see that we just need to rewrite these in a new way. So the first term is negative 3. Now this says minus x, but we could think of it as plus negative x. So our second term is negative x. This term, well, it's positive, so we're going to have 4x squared over 3. Now we can think of that as the term, but we're going to write this in a different way, and this will help us think of the coefficient too. Okay, so if we have 4 times x squared over 3, this is equivalent to 4/3 times x squared. Okay, so basically, let's do this on the side, just to convince you. If we had 4/3 times x squared, okay, to multiply fractions, I could write this x squared over 1. We multiply the numerators, well, that's 4x squared. And we multiply the denominators, that's 3 times 1 is 3. Okay. So sometimes we will have forms like these, but when we want to write them in terms of their coefficients, you could basically just take out the numbers and write that as the fractional number multiplied by the variable part. Okay. Now here we have negative y over 2. Okay. And this can be problematic. A lot of times students want to just write that the coefficient is negative 2 because you see a 2, but that 2 is in the denominator. So let's think of this as negative 1 times y over 2, which we could say is equivalent to negative 1/2 times y. Okay. So in this case, when the variable doesn't seem to have a coefficient in the numerator, remember the invisible coefficient is 1. Okay? And to write this as a term, we should write this as negative 1/2 y. Okay? So again, the main reason is we like to write it as a constant number multiplied by the variable part, whatever it is. Okay? And then once you've written the terms, if you've written them this way, the coefficients are easy to identify. The coefficient of a constant is itself negative 3. Now this says negative x. Remember, this means negative 1x. You do not include any variables in your coefficients. They are always numbers. So this is equivalent to negative 1 times x. So negative 1 is the coefficient of this term. Okay. We would write it like this, but you could write it as negative 1x. Okay. Here, the number multiplied by the variable component is 4/3. And in this last term, we have negative 1/2. Okay. So again, just note, if you have fractional components, think of taking out and writing as a product the number parts with the variable parts. Remember, if a variable doesn't have a number in front of it, you can think of that coefficient as 1, negative 1 in this case, and we thought of this as a 1, which we changed to negative 1/2 in this case. Okay. And in this example, we're going to, in part B, sort the terms below into groups of like terms. Hint, there are 7 different types of terms. Okay. So let's be systematic about this. Okay, so there's about 20 terms here. Okay, so I want to find all the like terms. So I'm going to start here. Okay. 5a. And now something is a like term with 5a if its variable part is also a. So I'm going to go through and see if I could find any other terms. Well, there's one, negative a. Its coefficient would be negative 1. Its variable part is a. Okay. Notice here there's a capital A, but we distinguish between lowercase letters and capital letters. Sometimes we like to use them, or when we use lowercase as opposed to capital, they represent different variables. So capital A and lowercase a are not the same. So I'm going to keep moving on, and I'm going to cross out the ones I get as I get them. That's a capital A. Here I have a 6a. I'm going to cross it out so I know I did it. And here we just have a regular old A. Okay. Now I think I got all of them, but as I go through the chart, I'll cross out all the ones that I've done thus far, and then if I miss anything, I can see what's not crossed out at the end. Okay. Now the variable term here is t. The coefficient is 11, so we have 11t. Now I'm going to go through and look for anything that just has a single variable of t. That has multiple t's and p's, so that doesn't work. Scrolling along, negative 5t. So these are like terms. Okay, too many t's. Then we have 4t. I'll cross that out. Too many t's. None of those have t's, and it looks like I found them all. Okay, we'll call this G1 for group 1. Here's group 2. Okay. Next we have 3 TTP. So we have 2 factors of t and 1 factor of p. The coefficient is 3. And remember, another way to write 2 factors of t is t squared. Okay. So let's scroll through and see if we see any more. So we need 2 factors of t. But this has 2 factors of p because the p is squared, so this would not apply. Here we have 2 factors of t and 1 factor of p, so this is a like term. No. Here's 2 t's and 2 p's. We need 1 p. And notice this has 2 factors of t. They're separated, but they're equivalent, and 1 factor of p. So this does fall in this category. So negative 6 tpt. Call that group 3. Okay. It's now 4xy. So we want to find anything that has a single x and single y variable product. Okay. Well, this one has an x and a y. It's written really funny, and we can write a simpler equivalent expression, but it has 1 factor of x and 1 factor of y. That has too many. That has z's in it. That is 1 factor of x and 1 factor of y. And I think we're done with those. Okay, so that's group 4. Next we have capital A. This group 5. And I'm pretty sure I only remember seeing one more. 4 times capital A. And we'd call that 4A. Okay, next grouping. 2 factors of t and 2 factors of p. Let's move this over here. So negative 3 ttp squared. Okay, these have x's and y's. Here's something with 2 factors of t and 2 factors of p. So negative 8 ttpp. So this is group 6. I'm just keeping track of them to make sure I have 7 in the end. And let's make sure we cross them all out. And now here we have 2 factors of x, 2 factors of y, and 1 factor of z. So they should all be in this group, but I'm going to still double check as I go to make sure we didn't miss anything. So we have x squared, y squared, z. Okay, this has 2 factors of x, 2 factors of y, 1 factor of z, so this checks. Y, z, x, y. And finally, this has 2 factors of x, 2 factors of y, and a factor of z. Make a little more room. So negative 7 x, x, y, y, z. And that would be our 7th group. Okay, so we have sorted the terms below into groups of like terms. Okay, and honestly, they're usually not as complex as this, but it's good to do ones that are a little bit harder, so when we're dealing with variables like this, it'll be a piece of cake. See you at the next video.